This video is about the yellow material. The yellow material is an elementary material that students use to help explore and discover the area formulas for the rectangle, the parallelogram, and the triangle. Now we can use the same material for the adolescent work, except we're going to modify it and use it in a different way. While the elementary child will do a lot of numerical explorations first, and then the formula becomes just a summary of all their work that they've done previously, while the adolescent does do that a little bit, and that's how we do want to develop formulas, for things like this, where students have had experience with the formulas before, like they probably already do know how to find the area of a rectangle, and for triangles and parallelograms, they've probably seen it before at least, even if they don't remember it exactly or not remembering where it came from. This work with this material and these early lessons are really about not so much the formula itself, but more about the process of how to create a formula with area. The idea that we always turn things into rectangles and then we can relate that back to the original shape. So with this work, we start by introducing the yellow material. We do it much more quickly with adolescents than we would with elementary, again, as it's probably generally review. But if students do need more time with it, then that could be part of their follow-up work, whereas other students can move on more quickly. I'd like to show you what's in the yellow material and talk about it just briefly, and then we can talk about how we modify it a little bit for the adolescent. There are 4 rectangular pieces, and what this is really trying to do is get the students to see this final piece here as being made of horizontal and vertical lines, and that we can do the measures around here, like these tick marks are representing the squares that we would have here, so that students would say, oh, it's 10 by 5 to get 50. This work is really important for the very young child who hasn't had a lot of experience with multiplication and dealing with arrays. But for our students in the adolescent work, really we just start with this here. I don't think I've ever actually introduced these other 3 pieces for the adolescent. Instead, we just start with this piece here, and we'll do this as a review of what area really means. And that's what's important, is that sometimes students work with ideas like perimeter and area and volume, and they're just kind of going through the motions of putting things in a formula. But we need to remember, what is area? Like, what's the definition of that? And the best way to examine that is with a simple example, and that would be the rectangle. So we just use this one piece for the rectangular work from the yellow material. For the parallelogram and the triangle, we have one main piece, which is the shape itself. And then we have other pieces which are the original shape, but broken up into various pieces. So it's kind of like a little puzzle. And the goal is to be able to take the broken up pieces and rearrange it to the rectangle. And the rectangle will always be the same area as our original. So everything goes back to this 10 by 5 rectangle, whether it's the parallelogram with its pieces, or whether it's the triangle and their pieces. For the triangles, we have 3 different types of triangles. There is an acute triangle, which happens to be isosceles as well, and then there's different ways to break it up. And this is really the only one that I use. I can definitely use the other ones as well, but I leave those up to the students to explore if they wish. Because again, most of the adolescents have seen the formula for the area of a triangle before, and they don't need all the repetition and all the specific examples necessarily. But it's there and it's available if they want to do that. So we have the acute triangle, there's a right triangle, and there's an obtuse triangle. And these, again, have a whole piece and then another one that's been broken up into various parts that can be rearranged. It's nice to have a material that's really solid and very accurate like this. And if we have students who have come from Montessori Elementary before, it's a nice callback to that work. And we can do it in such a way where it's not, oh gosh, I'm doing work I did in 2nd grade again. We're doing it in a brand new way and with a lot more speed and with a different emphasis. So it's fine to use this material. For students who haven't had Montessori before, it's just a brand new material, and so they aren't missing anything by not having it previously. If you don't have the yellow material, then you can easily recreate it using construction paper. And in fact, for a lot of the activities beyond this, we're just going to be using construction paper anyway. There aren't really any wooden materials in Montessori for that. There are some materials for some of the shapes. for area using metal insets, which we could use with our adolescents, but I find that just doing the work with construction paper or templates and having the students work in a different way is really valuable for this age group. So that's just a little introduction to the yellow material, and then I'm going to do some more lessons where I show specifically how we derive the area formulas kind of in this progression from the most simple to the most complex.